today's video, I'm going to teach you how to do a problem related to definite integration. This is a very unique problem and very popular and a very important problem examination point of view. So let's learn how to do the integration 0 to pi by 2 log of sin x with respect to x. For this, we are going to use one property of definite integration. One of the important rule of definite integration, that is integration from 0 to a f of x with respect to x. This is equivalent to 0 to a f of a minus x with respect to x. So to solve this question, we are going to use this property. Welcome to my channel. I hope you have gone through my previous videos related to definite integration. And in today's video, I thought why not to do a very demanded problem, very unique problems, and examination point of view, very IMP problem. I hope you'll enjoy and you'll learn something from this video. So let's start today's problem, integration 0 to pi by 2 log of sin x with respect to x. Here is the property 0 to a. So in our question 0 to pi by 2, that implies a is equivalent to pi by 2. So using the property, so first of all, call it as equation 1. Now after using the property, 0 to pi by 2 will as it is, the limits will not change, only the function will change. Here is a f of a minus x. So this is log of sin x is nothing but f of x. Now applying the property, so log, in place of x, we have to write down a minus x. So log of sin, and in place of x, a minus x, that is pi by 2 minus x with respect to x. And we know that sin pi by 2 minus x equals to cos x. This is formula from trigonometry. Therefore, I equals to 0 to pi by 2 log, and log sin of pi by 2 minus x nothing but cos x. So it becomes log of cos x with respect to x, call it 2. So we have the two expression 1 and 2. Now we will be adding 1 and 2. So adding 1 and 2. So now adding 1 and 2, we get I plus I equals to 0 to pi by 2 log of sin x with respect to x plus 0 to pi by 2 log of cos x with respect to x. So I plus I equals to 2i, and we know the one property a to b f of x with respect to x plus a to b g of x with respect to x. This is equivalent to a to b f of x plus g of x with respect to x. Therefore, this expression can be written as 0 to pi by 2, then log of sin x plus log of cos x with respect to x. After that, we know one property of logarithm, that is log a plus log b is equals to log a into b. A is multiplied to b. This is a property. This property can be utilized only when the logarithmic base are same. That is log a to the base e and log b to the base e. When the bases are equal, then only you can apply this property. So sum to multiplication property of logarithm. Therefore, here we can write 2i equals to 0 to pi by 2. Here is a equals to sin x and b equals to cos x. So a into b, that is sin x into cos x. So this can be written as log of sin x multiplied by cos x, and again now with respect to x. And from trigonometry we know that 2 sin a cos a equals to sin 2a. This is a property from trigonometry. And in our question, here is a 2 is missing. So multiplying and dividing by 2. Therefore 2I equals to 0 to pi by 2 log of, now 2 sin x into cos x equals to sin 2x divided by 2. Now integration with respect to x. Now applying another property of logarithm, that is log a upon b to the base e equals to log a to the base e minus log b to the base e. When no base is given, the base e is assumed, the base e present over there. When base e is present, we don't write, we just write logarithm. So this is equals to what? So 2I equals to 0 to pi by 2 as it is. Now log a upon b, so that is equals to log sin 2x minus log 2 and integration with respect to x. When I have not written base, it is assumed the base e is present over there. When the base e present, we don't write. Now this problem can be split into the two parts. This is the first part and this is the second part. Let us call as the first part as a I1 and the second part as a I2. Now let us find out the integration separately and get the result of I1 and I2. Therefore 2I equals to I1 minus I2. Now let us take I1. I1 equals to integration 0 to pi by 2 log sin 2x with respect to x. Now we can do this integration by using substitution method. So let 2x equals to t, differentiating, so 2 equals to dt by dx implies dx equals to dt upon 2. One more important thing, whenever we apply substitution method, the limit of definite integration also change. So we have t equals to 2x, x equals to pi by 2, then t equals to 2 into pi by 2 equals to pi, and x equals to 0, then t equals to 0. Therefore I1 equals to new limits. What are the new limits? In place of 0, 0, but in place of pi by 2, now we'll get pi here. Here is a log, here is a sine, and in place of 2x, t will come, and in place of dx, it is a dt upon 2. So this is equals to 1 by 2 taken common, and 0 to pi, and log of sine t with respect to t. Now applying the property of definite integration, that is 0 to 2a f of x dx is equals to 0 to a f of x with respect to x plus 0 to a f of 2a minus x with respect to x. This is important property of definite integration. So applying above property, 1 by 2 integration 0 to pi by 2 log of sin t with respect to t plus half 0 to pi by 2 log of sin pi minus t, because 2a minus x, 2a, that is a is the pi by 2 minus x, in place of x here is the t, so 2 to get cancelled, so that equals to pi minus t. Therefore log of sin of pi minus t with respect to t. Since sin of pi minus theta equals to sin theta, therefore sin of pi minus t equal to sin t. So this much part becomes sin t. Therefore I1 equals to half 0 to pi by 2 log of sin t with respect to t plus half 0 to pi by 2 log of sin t with respect to t. Therefore I1 equals to half is common, 0 to pi by 2 log of sin t with respect to t plus 0 to pi by 2 log of sin t with respect to t. I1 equals to 1 upon 2. Both the terms are same, therefore 2 multiplied by 0 to pi by 2 log of sin t with respect to t. Now we have the property of definite integration. A to b f of x dx equals to a to b f of t with respect to t. Therefore, I1 equals to half, here is a 2, and it becomes 0 to pi by 2 log, in place of t I can write now x by using this property. This 2 and 2 get cancelled, therefore I1 equals to 0 to pi by 2 log of sin x with respect to x, implies I1 equals to I. Since we have I1 equals to I, going back to the previous step, we had 2I equals to I1 minus I2. Therefore, we can write 2I equals to I1 equals to I, therefore writing I here, and I2 nothing but log 2 to the base e 0 to pi by 2 integration 1 dx. So 2I minus I equals to minus log 2 to the base e, integration of x is, integration of 1 is x, and the limits are 0 to pi by 2. So I equals to minus log 2 to the base e, upper limit minus lower limit, so that is equals to minus pi by 2 log 2 to the base e is the solution. If you wish to remove the negative symbol, then pi by 2 as it is. Here is a log, in place of 2 you can write log of 1 upon 2. This is the final result. How did you find this solution? Have you got through all the steps? Was there any problem in my presentation? If you find any difficulty, if you don't like the presentation, if you don't like the method I have solved, please let me know. Write down your comment in the comment box. Meet you again with another type of problems, similar type of problems with another topic. Till then, wish you good luck. All the best.